Hello, I'm Mr. Rogers and you're watching the video notes here, but this is section 1-3 in your book, guys. And in section 1-3 we're talking about waves, light waves, sound waves, and kind of a big question. You don't have to write this question down. So if you write this question in your notes when I check them in class, I'll know you were not listening. But the question for these notes, kind of think about, what does an echo, a shadow, and your reflection have in common? So what is related? What kind of ties those three things together? Maybe we'll get an answer to that in your own head there after you watch these notes. So we're talking about how waves kind of interact with each other. What happens when waves hit something or bounce off of something? So when we think about this, we think about how waves can maybe bounce off of things. I think of like a reflection. So here we have a nice beautiful mountain. You can see it's reflecting off the pond. And so that light wave is actually bouncing off. And when we think about this, we think about reflection is when a wave hits an object, it cannot pass through, it bounces back. Think about a mirror, your reflection is bouncing back. And when this happens, there's a couple specific things that happen. There's what's called an angle of incidence, and that's the angle between the incoming wave and then like an imaginary perpendicular line running there. And also the angle of reflection is the angle between the reflected wave and the imaginary line, so kind of bouncing out. So we think about it here, go back to my picture. The angle of incidence is like that light coming in, and reflection is it bouncing out. And those angles are the same. There's that imaginary perpendicular line to, like, let's say that's the mirror right here. So there's the incidence of the angle coming in. That's got to be the same going out. So incidence coming in, reflection, and they are going to be the same. So if you bounce a ball in, it's going to bounce out at that same angle from that perpendicular line. All right. So the next thing, things can refract. Aha. Remember our phones and our lights we use with the triangular prisms? That light was refracting. So when a wave moves from one medium into another at an angle, it changes speed, which causes it to bend. We saw this yesterday. So when light hits that new medium, here the light's in the air, now it hits the water, and it bends. So you can see that angle there, that's that refraction, that light's being refracted. Think about like lenses. You have glasses or contact lenses. You're refracting that light, you're bending that light as it goes to that medium there. So that's refraction, when that light bends, when it changes mediums, when it changes, it speeds up or slows down, and that's what causes it to bend right there. So we have reflection, we have refraction, and we have diffraction. So diffraction is when a wave passes through a barrier, it bends or spread out. And this is kind of particular with, like, think about sound waves. So obviously here's Jill talking, looking for Jack, trying to yell through the doorway. Even though they can't see each other, those sound waves will carry and bend around that barrier or diffract so that Jack can hear it. So just these three basic ways that waves kind of interact we're going to focus on today. The idea of, again, reflection. So when things are, where is it at there? Bouncing off of objects, it's reflecting, comes in at the same angle, goes out as. We have diffraction, and this is when it kind of bends or changes its direction because it changes speed as it changes mediums. And diffraction is kind of bending around a barrier as it goes through. So 8th grade, we thank you guys for watching, and we will see you along